For Unit 4 of Module 3 Geometric Design of Highways and Railroads, we are going to discuss about the second type of sight distance, which is decision sight distance. Now for this unit, the learning outcomes would be to determine the decision sight distance and differentiate it with the stopping sight distance that was discussed on the last video, that is on Unit 3 of this module. So, when stimulus is unexpected or when it is necessary to make unusual maneuvers, longer SSDs or stopping sight distances are usually required since the perception reaction time is longer. If you will recall, the two components or two parts of the stopping sight distances are the brake reaction time or the brake reaction distance and the actual braking distance. So for decision sight distance, we provide a longer amount of time when there are certain scenarios wherein it is required to give more time for the driver to decide on what type of maneuver will be done. Will it be a stop? Will it be a change in speed, change in direction, and so on? So decision sight distance is defined as the distance needed for a driver to detect an unexpected or otherwise difficult to perceive information, source, or condition in a roadway environment that may be visually cluttered, recognize the condition or its potential threat, select an appropriate speed and path, and initiate and complete complex maneuvers. So for decision sight distances, we do not necessarily stop or put to stop the vehicle, but we apply some complex maneuvers such as the changing of speed and changing of a certain path to initiate or to prevent danger from these scenarios. So because decision sight distance offers drivers additional margin for error and affords them sufficient length to maneuver their vehicles at the same or reduced speed rather than to just stop, its values are substantially greater than stopping sight distance. Take note that decision sight distance, when you are going to consider the same speed or design speed, it should be greater than the amount that is required for the stopping sight distances. So for this one, similar to our decision sight distance, you will have a longer reaction distance, and this one is not necessarily braking distance. This can be any type of maneuver. For example, this may be a change in speed or the change in path. So let's just call this one again from our basis of these provisions, Ashto, Green Book 2011, Chapter 3, page 7, drivers need decision sight distances whenever there is likelihood for error in either information reception, decision making, or control actions. So, when there is an error, a likelihood in error for these three, in the information reception, decision making, or in control actions, whenever it is hard to have this, or it is harder to apply or do these control actions, we provide decision sight distances. Examples of critical locations where these kinds of errors are likely to occur and where it is desirable to provide decision sight distance include interchange and intersection, locations where unusual or unexpected maneuvers are needed. We also provide DSD when changes in cross sections such as toll plazas and lane drops occurs, and also for areas of concentrated demand where there is apt to be visual noise. So what are these visual noise? These are competing sources of information such as roadway elements, traffic control devices, and advertising signs. So whenever there is a lot of objects that is present in the intersection, for example, or in a roadway, there is visual noise because there are a lot of things that you need to process, a lot of uh, objects that you need to consider. And with that, you need a lot of time or more time to decide on what action to do. So some of them, for you to have an idea, this images here, exit ramps. Whenever you will encounter an exit ramp, it is desirable to provide a decision site distance to consider likelihood for error in reception and decision making on whether to enter the exit ramp, especially when you are not familiar with the location or of that specific area. Maybe you would want to have more time to decide on which area or on which road you are going to pass through. Will you go to this road or the other? So whenever there are exit ramps, we provide decision site distances. And this one here is an example of a lane drop. A lane drop is a change in the size of the lane. For example, if this portion here is wider than this portion, the lane drops at this part. Okay, so that is a lane drop. For intersections, it is also desirable to provide decision site distance to consider likelihood for error in reception and decision making on which way to go in an intersection. So for intersections, of course, there are many ways to go here. So you need more time to decide on which way to go, especially like what I've said, if you are not familiar with the place that you are in. For toll plazas, it is desirable to provide DSD to consider likelihood for error in reception and decision making on which toll gate to choose. For example, if you will decide if you will pay in cash or you will pay using the RFID. And for lane drops, like this one. Lane drops are a place on a freeway where a main lane terminates by either becoming an exit-only lane or by way of simply ending and merging into the adjacent lane. So an example of a lane drop is this portion here, wider, and then it drops to a relatively narrower lane width. Okay, this is an example of a lane drop. Also this portion here, I think the lane ends here, so that's a lane drop. It decreases its lane width. So here, this is Shibuya crossing. If you'll notice, it is necessary to provide decision site distance here because there is a lot of visual noise that is happening here. A lot of pedestrians, and of course you also need to consider the other vehicles. You can see advertisements here, so that may affect your decision making, your perception or reception of information. So those are what we call visual noise. And from competing, those are coming from competing sources of information such as roadway elements. You have pedestrian lanes here that are a lot. So you have traffic, meaning pedestrian traffic and those motors, and traffic control devices such as there are a lot of pedestrian elements here, stoplights, and advertising signs. So in this case, we need to provide decision site distance for the drivers to maneuver. And besides the visual noise that is occurring here, this is also an intersection. So those things are considered. The decision site distance in table 3-3, of course this is still from the AASHTO Green Book 2011, may be used to provide values for site distances that may be appropriate at critical locations and serve as criteria in evaluating the suitability of the available site distances at these locations. Because of the additional maneuvering space provided, decision site distances should be considered at critical locations or critical decision points. We have given some critical locations and critical decision points earlier, and should be moved to locations where sufficient decision site distance is available. If it is not practical to provide decision site distance because of horizontal or vertical curvature, or if relocation of decision points is not practical, special attention should be given to the use of suitable traffic control devices for providing advance warning or the conditions that are likely to be encountered. So whenever there is restriction in providing decision site distances, we provide traffic control devices such as signages, or we can provide traffic lights for us to guide the drivers to in their decision process making, and also to avoid accidents that may occur if it is not provided. So we have your table 3-3 for decision site distances. Again, for different design speeds, we have your decision site distances for different avoidance maneuver that is presented in the portion here at the bottom of the table. We have your metric and the English units. So for avoidance maneuver A and B, those are if the decision or if the only maneuver that is applicable is to stop. Okay, I told you that decision site distances is not necessarily stopping. Okay, but you may also change your speed, your path or direction. So these are different areas or different types of maneuvers. So if you are going to stop on a rural road, you are going to consider the time for the maneuver, for avoidance maneuver, to be equal to 3.0. For urban roads, 9.1. Of course, we are giving more time in urban roads because there are a lot or relatively more traffic considerations in urban roads. So C, D, and E avoidance maneuvers are similar. It's just that they are just varying in the type of road on which you are designing. Okay, so decision site distance criteria that are applicable to most such situations have been developed from empirical data. The decision site distances may vary depending on whether the location is on a rural or urban road or on the end of the type of avoidance maneuver needed to negotiate the location properly. So as I have discussed a while ago for these types of avoidance maneuver. Table 3-3 shows decision site distance values for various situations rounded for design. As can be seen in the table, shorter distances are generally needed for rural roads and for locations where a stop is appropriate maneuver. So this means that if you will notice here, the only maneuver V is for stopping in urban roads, and they are really larger as compared with stopping on a rural road. That is because we are providing, as I have told you, we are providing more time for the driver to execute this avoidance maneuver because there are more traffic elements in an urban road. Okay? For the avoidance maneuvers identified in Table 3-3, the pre-maneuver time is greater than the brake reaction time for stopping site distance to allow the driver additional time to detect and recognize the roadway or traffic situation, identify alternative maneuvers, and initiate a response at critical locations on the highway. This is what I was telling you earlier in the image that I have shown you. We provide more reaction time. Okay? Pre-maneuver time is the counterpart of the brake reaction time in stopping sight distance. So we give more time in for the driver to be able to assess the situation on whether there is really the perceived object is really an obstruction or it will really cause an accident, and for the driver also to have more time in deciding on what alternative maneuvers to do. The pre-maneuver component of decision sight distance uses a value ranging between 3 and 9.1 seconds as demonstrated by this portion, avoidance maneuver A and B for stopping. For rural roads, that is 3, and for urban roads, 9.1. The braking distance for the design speed is added to the pre-maneuver component for avoidance maneuvers A and B as shown in equation 3-4. Okay? So yun yung braking distance is added on the pre-maneuver component. So these times here are for the pre-maneuver component. Whenever we will stop, then we should use this pre-maneuver, or you will add the pre-maneuver distance to the braking distance. Very similar to the stopping sight distance actually. We are just changing the value of the time that we are providing. Braking component is replaced in avoidance maneuver C, D, and E with the maneuver distance based on maneuver times between 3.5 and 4.5 seconds that decrease with increasing speed in accordance with equation 3-5. So for avoidance maneuver C, D, and E, we are not stopping. So we are not really changing, or we will not add the braking distance in that case. But we will just consider the pre-maneuver, or we call it the total maneuver time for the driver, and it is shown here by this different time considerations or time interval considerations. So here, this is similar to the sight distance. It's just that for if the option for the driver is to stop, and that is avoidance maneuver A and B. So if you're going to stop, then you will use this formula. You will add the considerations for this value. Take note that for the formula that I have given you, this is equal to, of course, these are just the numbers before them, or the coefficients are just what they call this, they are just our conversion factors, but really this is, if you are going to consider, this should be the formula, still similar to our stopping sight distances. Okay, it's just that for decision sight distance we are changing the value of t. Remember that for stopping sight distance we just provide 2.5 seconds, but for decision sight distance we provide more time for them. Okay, so there you go. Decision sight distance for avoidance maneuver C, D, and E. As I have told you, we will not be adding the braking distance because we are just using avoidance maneuver C, D, and E, and that is we are changing the speed, the path, or the direction on which the driver will maneuver. We are not really changing, or we are not really stopping our vehicle. So in that case, you just consider the first portion for considerations, V sub O times T, wherein T is the total pre-maneuver and maneuver times. So for C, D, and E, you have in the table the values. These values is the total maneuver time. Okay, those are difference for C, D, and E. Okay, so that is the one that you will use in this formula. So I will not be giving you examples on this one. You can just base it on the uh, examples that was given in stopping sight distances, because it is really just a matter of uh, substituting values. Okay, you can just review on that previous video that I uploaded. So, as a review of the concepts, decision sight distance offers drivers additional margin for error and affords them sufficient length to maneuver their vehicles at the same or reduced speed rather than to just stop. Its values are substantially greater than stopping sight distances. So, thanks for watching again. I'll see you on the next part of this module, which is on the intersection sight distances.